Okay, if we're trying to find our reference angle, we first got to graph the angle. So let's just graph what we got here. So for number 42, we're going to graph 7 pi over 4. Now, when you get good at this, you see 7 pi over 4, you're like, psh, I know where 7 pi over 4 is right away. Do you guys know where it is right away?
Yeah.
Fourth quadrant? Yeah, fourth quadrant. And I know that right away because if I go pi, that would be 180, right? Okay, I want to write that with a denominator of 4 because then it helps me see where the 7 pi over 4 is probably going to be. Now, if I have 4 pi over 4 right there, that means there's 4 sections right here. 1 pi over 4, 2 pi over 4, 3 pi over 4, 4 pi over 4. We got that? We got that. Okay. So if I go another half circle, what would the angle measure be right here? 8 pi over 4. Oh, which just passes 7 pi over 4, right? So we have 5 pi over 4, 6 pi over 4, 7 pi over 4, and then 8 pi over 4. Ooh. So 7 pi over 4 is right here. All right, so if 7 pi over 4 is right there, and then we draw our triangle. Remember, triangles go out from the origin and then back to the x-axis. What would this angle measure be right here? Yeah, you guys said 45 degrees, which is good, but we're in radians right now. Pi over 4. So theta, while it equals 7 pi over 4, our reference angle equals pi over 4. And my sketch right here satisfies the last part, which is sketch theta and theta prime in standard position. Theta prime is in there. And then you guys can see I should draw this arrow right here to represent theta. Okay. And I might as well label that too. Just let me recap really quick. This little line right here that I labeled theta, that is 7 pi over 4. Okay? The reference angle is whatever the angle is back to the x-axis. Okay? So like for example, if I had an angle that went like this and stopped right there, this might be theta. The reference angle would be the angle back to the x-axis.
Oh, the closest one?
Yeah. It'll always go back to the x-axis and never goes to the y-axis. It always goes back to the x-axis. That's how I know what the reference angle is. Now, in our case right here, we went 7 pi over 4, and we know that one complete rotation is 8 pi over 4. And so how many more pi over 4s would it take to get to 8 pi over 4? 1 pi over 4. That's why I have this. So what do we use reference angles for? We use reference angles to help us find the trig values of the angle. So like, let's say I wanted to find sine of 7 pi over 4. What you're going to think about is sine of pi over 4. This is what you're thinking about. What is sine of pi over 4? That is rad 2 over 2. Right? And so what is the value of sine of 7 pi over 4? Negative rad 2 over 2. Good. You guys didn't mess up on that. How come it's negative? Because we're in the fourth quadrant. The y value is negative. We're going down. The y value is negative rad 2 over 2 right here. So that's why we know that our answer there is negative. So that's how we can use reference angles.